Question 5, we have a solid cone with a slant height of 15 and a vertical height of h. We have to show that the volume of a cone is given by 1 upon 3 pi 225h minus h cube. So we know that the volume of the cube is given, which is 1 upon 3 pi r square h. Now, in the given expression, it does not contain r, so we have to find h in terms of r. Now, let's say this is r and this is h. So we can say that 15 square is equals to 8 square plus r squared, which means r squared is equals to 15 square is 225 minus 8 squared. Substituting the value in the formula, we have 15 into pi 1 upon 3 into pi into r square, which is 225 minus 8 square multiplied by h. Expanding the bracket, we get 1 upon 3 pi into 225h minus h cube. In part 2, it says that given that h can vary, find the value of h for v has a stationary value. So stationary value basically means that the dv by dh would be equals to 0. Now we know that v is equals to 1 upon 3 pi into 225h minus h cube. And for the stationary value, we'll find dv by dh and put it equals to 0. So differentiating this, 1 upon 3 pi will remain as it is a constant. This will become 225 minus 3h square. Now substituting 0 over here, we'll get 0 is equals to 1 upon 3 pi into 225 minus 3h square. So the 3 will multiply by 0 and the pi will divide by 0 will give us 225 minus 3h square is equals to 0. So h square is 225 divided by 3, which is 75, which means h is equals to square root of 75. For the nature of the stationary value, we'll differentiate the function again. So differentiating the function again, we get d square v upon dh square, which is equals to, so 1 upon 3 pi will again remain as it is. The 225 will become a 0. And differentiating minus 3h square, we get minus 6h. Substituting square root of 75 over here, we'll get 1 upon 3 pi into minus 6 into square root of 75. Now, as we have a negative value, we know that the double derivative will be less than 0, which means that this will be a maximum point.